Right. It's going to be smaller than -1. Okay. Let's think about that one for a moment. Can we possibly get a number that's going to be both bigger than -6 and smaller than -1? Alright. Let's just try smaller than -1. So say -2. -2, that is going to be bigger than -6. And it's also smaller than -1. So that will work out for us. Alright. So it made sense there. Let's go ahead and let's work out one more of these. This time we're going to play with one that's literally is going to be two equations, but at different times here. We have the problem -3x minus 7 greater than or equal to 8. This is our other case of inequalities because we have an OR in this situation. And we have -2x minus 11 less than or equal to -31. So now we have a two-part situation. And since we have the word OR, we can actually get situations where it's like, well, it's either smaller than 2 or it's bigger than 100. Notice that while there's a big gap in the middle of those two, they go in the opposite direction. And we've also said it has to either fall in one or the other. It doesn't have to be both at the same time. When it's a nice joint sentence like it was up here, it had to be both at the same time. But now we have an OR situation. So now we'll just go ahead and solve both of them separately. So we'll add 7 to both sides. We get -3x greater than or equal to positive 15. Divide that one by -3. And that gives me x. Remember, since we divide by negative, we're going to switch our sign. And now I have a -5. Okay. Good fun start there. Now we go to the other side. We add our 11. Add 11. I get -2x less than or equal to -20. Alright. So, divide by -2. Divide by another -2. That'll give me x divided by a negative, so I got to switch my sign around. And I get a positive 10. Okay, so I have a number now that I say, well, it's either got to be smaller than -5, or it's got to be bigger than positive 10. So they're two very different situations, but since we split it up with an OR, you can carry that through the whole situation here. Since we have an OR, that's okay. We're technically allowed to have that. But if we have something that's all joined together, that's like saying it has to be this and it also has to have this. It has to be smaller than -1 and bigger than -6. Right? So now let's practice graphing with these. Okay. So first case scenario, we'll make our number line. All right. Give it a shot. Make sure you do it in pencil. Because, of course, you may have to erase or alter stuff, but that's okay. That's what math is about. All right. We have ourselves 2 points of interest. Remember, always put them in order. 12, 14. Might even put in a couple extra points here outside of our point of interest. So we might do like 11, 12, 13, 14, and let's put 15 in there. Okay. And we're going to put 2 circles up on our graph. We have the point 12 and the point at 14. Let's see. Notice here 12, that one is open, so we leave that one as a nice open circle. 14, that one is closed, which means we will shade that one in. Okay. Now, according to our little arrow rule, it says from 14 we have to go this way we have to go to the left. And 12 is telling us that we have to go this way, to the right, which is something that we should expect. If we have an AND situation, then basically we're saying, well, it has to fall between those two numbers. If we have an inequality that is an AND, then it should be in between the two numbers. With an OR situation, we may not get that, but since this one is an AND inequality, should be in between like that. Whoop. Oh no, my computer's asleep. Well, you might not see it, but I can see it. Okay. Alright. So, next set of problems here. We have our points of interest are going to be -6 and -1. Remember, smaller numbers over this way, and even though 6 is bigger than 1, we're playing with negatives. Right? -7 would be off over here. Say 3 would be in here. And 0 would be over here. Alright, be very careful with these number lines when we play with them. Alright, and we're going to put 2 circles at our point of interest. Okay. Alright. And let's see here. So -6, that one is closed. -1, that is also closed. Alright. And tell you what, let me just go ahead and address one mistake I made up earlier. Notice up here, I didn't quite put my interval in between the line. So let's make sure that we basically shade it so that we know that, okay, it is all the points that fall on that number line and not necessarily just up above it. I have to admit, I had a lot of teachers who said, you know what, it's okay, we'll put them above. But we don't want to be doing that. We want to say it is these numbers and not some numbers that fall somewhere, someplace, but they fall on the number line. Okay. So let's see, according to this, it should be this way from -6, since our sign is indicating to us this way from -6, and it should go this direction from -1. So it goes this way, and it goes this way. Alright, and we want to make sure that we're saying it's on that number line. There we go. Alright, now notice here though, I'm not putting any arrows, like I'm not saying, yes, it will go forever this way, and putting an arrow out past -6, because it can't be any smaller than -6. So in this case, these are very finite, so keep in mind, we haven't been putting any arrows yet. And with AND inequalities, when they're one joint statement, we shouldn't be getting any arrows. It should actually be falling in between something. But what happens if it's an OR? Let's find out. Hopefully you're practicing this one out. Alright, so this one we literally separated our number line with an OR statement. We said, alright, -5, that falls here. 0 always comes in between any negative and positive number. I go out here and say, alright, well, there's -6 over here. Might have point like 11 over here. Admittedly, I put a little too much space in between some of my numbers here, so I kind of had to squeeze there at the end. Alright, and our point of interest is going to be at -5 and at +10. Okay, so we have our points of interest. And now, let's look here. At -5, it is closed. +10, it is also closed, since we have an equal sign. Alright, and according to my arrow rule, it says I should be going to the left from -5. So, yay there. Make sure we have an arrow saying, okay, it's all numbers that will go on forever. Since I have nothing blockading me, since I'm going opposite of +10. And in +10, we'll notice it says, alright, we are going to go to the right. So it means it goes off in this direction, and it will continue onwards forever as well. So there we have had a little bit of practice. Keep in mind, with the OR situation, we expect our inequalities to sort of part ways like that. And with an AND, we expect them to basically join up and fall in between the 2 points. So we'll talk a little bit, perhaps on another video, about how there might be cases where the two of those rules kind of don't necessarily fall in line. For the most part, we expect this. The other ones are kind of weird when they don't quite fall in like that. Alright. Let's go ahead and let's look at one other thought here. And that is, can we actually determine an inequality given only its graph? Let's go ahead and we'll draw out a couple of these. Also, I hope at some point you all take a moment to be able to stretch. I know this video is running just a hair long. But let's go ahead and let's try a couple of these. Okay. So let's start out with one where we have circle. And this one happens to fall at -3. And then another circle, like so. This point happens to be at 1. Okay. And then we have it connected like that. Okay. Well, what this is telling us is we have some value x. We have a point of interest at -3. And notice that since it goes to the left, that means it's going to be the numbers that are bigger than -3. We won't put an equal sign underneath since it doesn't allow us to have -3 as an answer. And we're also going to say that it is all numbers that are going to be smaller than 1. Okay? So now let's practice writing that as an AND statement. One solid inequality. We get -3, and we'll say it is less than x, and then less than 1. Okay? So notice it's the numbers that x is bigger than -3,